Greetings children. Welcome to the online classes. This is Aishwarya. Please like and subscribe the channel for the further updated videos. The following video is for class 6, subject General Science, chapter 10, Motion and Measurements of Distances, part 4. Part 1, 2 and 3 of this lesson we learned about what is the story of transportation. Then we learned how some measurements are taken and how we have to be precise, and we learned about standard unit. So continuing with, if you have your textbooks, please refer the textbooks. I'm reading from page number 102. They have given a small activity, moving things around us, about the things that are moving around us. There is an activity 5. Think of some objects you have seen recently. List them in the table. That is 10.4 objects that rest and in motion. Now after listing, these may include a school bag, a mosquito, a table, people sitting on chair, or people moving about. The list may also have a butterfly, a dog, a cat, your hands and small baby, a fish in water, a house, a factory, a piece of stone, a horse, a ball, a cat, a moving train, a sewing machine, a wall clock, or the hands of the clock. Make your list as large as you can. Which of these are moving, which are at rest? That is what you have to write in this. Objects which are at rest in the first column, objects which are in the motion. This is very easy for you to do, especially because you're at home. So many things will be going around you, so it will be easier for you to write it down. How did you decide whether an object is in motion or at rest? You did that list, right? Like if you take the list that is given on your screen, that is objects at rest are house, table and clock, and so objects in motion, a flying bird, second hand of the clock, right? How did you decide that these objects are at rest and these objects are moving? You might have noticed that the birds is not at the same place after some time, while the table is at the same place. On this basis, you may have decided whether an object is at rest or in motion, isn't it? Next, there is let us look at the motion of an ant closely. Now that comes along with the activity 6. Select a place where you find ants. Spread a large sheet of white paper on the ground and keep a little sugar on it. Ants are likely to be attracted on sugar, and you will find many ants crawling on the sheet of the paper soon. For any one ant, try and make a small mark with the pencil near its position where it has just crawled on the sheet of paper. With the pencil, the sharp pencil, you just can make a mark behind that movement of that ant. Okay, keep marking its position after a few seconds as it moves along on the sheet of the paper. After some time, shake the paper free of the sugar and the ants. Connect the different points you have marked with the arrow. You show to show the direction in which the ant was moving. Each point you have marked shows where the ant moved to in intervals of few seconds. Motion seems to be some kind of change in the position of an object with time, isn't it? So what is motion? Motion is nothing but the change in position of an object in a given time. Now in activity 5, where did you place the object like a clock, a sewing machine or an electric fan in your grouping of objects? Are these objects moving from one place to another? No. Do you notice movement in any of their parts? The blades in the fan or the hands of the clock, how are they moving? Is there the movement similar to that of an ant or a train? Let us now look of some type of motion to help us understand these differences. That leads us to different types of motions. So I'll tell you in brief about 3 different types of motions. That is your circular motion, then rectilinear motion, and pendulum or the periodic motion. Okay, so types of motions. I'm reading out from page number 103. You may have observed the motion of a vehicle on a straight road, march past of a soldier in a parade, or falling of a stone. What kind of motion is this? Now, a spinster in 100 meters race also move along the straight track. Can you think of more such examples from your surroundings? There's so many movements that you go in a straight line, some go in circular, and some are periodic. In all these examples, we see that the objects move along the straight line. This type of motion is called the rectilinear motion. So what is rectilinear motion? The object that move on a straight line, that type of motion is called the rectilinear motion. Next, there is one activity 7. Take a stone, tie a thread to it, and whirl it with your hand. Whirl means rotate it on your hand. Okay. Observe the motion of the stone. We see that the stone moves along the circular path. In this motion, the distance of the stone from your hand remains constant, isn't it? This type of motion is called the circular motion. The motion of the point marked on the blade of an electric fan of the hands of the clock are examples of circular motion. What is a circular motion? Movement in circle, like for example, movement of a fan. It is called the circular motion. The electric fan or the clock by themselves are not moving from one place to another, but the blades of the fan rotates, and so do the hand of the clock. If we mark a point anywhere on the blade of the fan or on the hands of the clock, the distance of this point from the center of the fan or the clock will always remain the same as they rotate. Now that is about the circular motion. In some cases, an object repeats its motion after some time. That is periodic motion. In some cases, an object repeats its motion after some time. This type of motion is called the periodic motion. Take the stone tied with the string that you used in activity 7. Now hold the string in your hand and let the stone hang from it. This is a pendulum. Pull the stone to one side with the other hand and let it go. Now the pendulum is in motion. It is an example of the periodic motion. A branch of tree moving to and fro, movement of a child on a swing, the string of a guitar, yes, a swing, then a string of a guitar or a membrane of a drum or tabla being played are all examples of the periodic motions, where an object or a part of it repeats its motion after a fixed interval of time. Did you observe a sewing machine as a part of activity 5? You must have observed that it remains at the same location while its wheel moves with the circular motion. It also has a needle that moves up and down continuously as long as the wheel rotates, isn't it? This needle is undergoing a periodic motion. You can observe this next time you visit a tailor. If you don't have a sewing machine at home, you can observe this movement when you visit a tailor. Have you observed closely the motion of a ball along the ground? Here, the ball is rolling on the ground, rotating as well as moving forward along the ground. Thus, the ball undergoes a rectilinear motion as well as a rotation motion. Can you think of other examples where the object undergo combination of different types of motions? We did many measurement activities and discussed some kind of motions. We saw that motion is a change in the position of an object with time. The change in its position can be determined through distance measurement. This allows us to know how fast or slow a motion is. The movement of a snail on the ground, a butterfly flittering from flower to flower, a river flowing, an aeroplane flying, moon going around the earth, and the blood flowing inside our body shows that there is motion everywhere around us. So that completes this lesson. I hope you have understood. Stay at home, stay safe, take care of yourself, and keep learning, children. Thank you.